At the end of the last episode, we left one question hanging in the air. If so many AI strategies fail because leaders approach automation backwards, what does success actually look like? Not in a glossy demo, not in a keynote, not in a vendor slide showing a perfect future. What does it look like inside the real world, where work is messy, regulated, emotional, physical, and full of exceptions? The answer is not replacing humans with machines. The answer is building human-machine teams that last. The most successful AI deployments do not begin with a model and search for people to remove. They begin with a job that matters, redesign the surrounding system, assign responsibility, measure what changes, and then embed the technology into daily operations until it becomes part of how the organization learns. For this episode, we need a simple framework for separating durable AI transformation from expensive experimentation. I call it scale. Start with the work. Connect the context. Assign accountability. Learn through measured pilots. Embed into operations. These 5 moves sound straightforward, but they are rarely done in the right order. Most failed programs start in the middle. They buy a model, launch a pilot, announce a savings target, and then discover the workflow, data, legal approval, training, integration, and human trust were never ready. Scale reverses that order. It treats AI as an operating system for better work, not as a shortcut around the people who understand the work. The first principle is start with the work. This sounds obvious, but it is the point where many strategies quietly fail. Leaders ask, what can AI do? Better leaders ask, where is work slow, repetitive, dangerous, error-prone, or emotionally draining, and what would better work look like for the people closest to it? That shift matters. It forces the organization to map the real task, not the idealized task. It reveals hidden handoffs, missing data, tribal knowledge, exceptions, incentives, and safety constraints. Often the first useful artifact is not a model at all. It is a clear map of where time is lost, where judgment is required, and where a machine could remove friction without removing ownership. It also stops AI from becoming theater. If the system does not improve the work itself, it is not transformation. It is just a more expensive interface. One useful example is UPS and its Orion route optimization system. The value was not that an algorithm magically understood delivery. The value came from embedding optimization into a physical network of trucks, handheld devices, driver routines, customer commitments, mapping data, pickup windows, safety constraints, and constant operational feedback. UPS has estimated that Orion can reduce miles driven by around 100 million annually, with major fuel and emission savings. But the lesson is not simply that route optimization works. The lesson is that AI creates value when it is shaped around the real movement of people, vehicles, packages, streets, weather, time pressure, and local knowledge. A route is not just a line on a map. It is a sequence of human promises. The business that must receive a parcel before closing, the apartment building with a broken buzzer, the road blocked by construction, the pickup that cannot be missed. The machine calculates. The human still navigates reality. The same principle appears in physical AI. John Deere's See and Spray technology uses computer vision to detect weeds and spray only where treatment is needed. Deere reported that customers using the technology in the 2024 growing season saw average herbicide savings of 59% across more than 1 million acres. That is not a chatbot story. It is AI touching soil, crops, chemicals, weather, yield economics, equipment maintenance, and farmer trust. It also shows why successful automation must respect domain knowledge. A farmer understands timing, soil condition, crop stress, herbicide resistance, weather windows, and the economic consequences of getting a pass wrong. The human does not disappear from the field. The farmer decides when to run, what to plant, how to manage risk, and whether the machine is producing useful work. The AI handles precision at machine speed. The second principle is connect the context. AI becomes useful when it can reach the knowledge, rules, history, and systems that shape a decision. This is why successful deployments often look less dramatic than the hype. They involve permissions, retrieval systems, clean data pipelines, evaluation sets, user training, security reviews, and integration with existing tools. Context also determines boundaries. The system needs to know what it is allowed to see, what it is allowed to say, when it should refuse, and when a professional must take over. Morgan Stanley's work with OpenAI is a strong knowledge work example. The firm embedded GPT-4 into advisor workflows so financial advisors could search internal knowledge, summarize meetings, and prepare follow-up actions. Crucially, advisors still review and adjust the outputs. The model reduces friction between knowledge and service. It does not replace the relationship of trust. Moderna shows a different version of connected context. Its AI story is not only about one spectacular model. It is about scaling capability across research, legal, manufacturing, commercial work, policy questions, contracts, and clinical data analysis. OpenAI reported that within 2 months of adopting ChatGPT Enterprise, Moderna had hundreds of internal GPTs across the company, with employees creating tools for the work they understood. That matters because scale cannot depend on a small central team guessing every use case. The people closest to the work see the repeated questions, the annoying bottlenecks, the documents everyone searches for, and the decisions that need better preparation. Durable AI gives experts a way to build around their own domain, while governance, security, and shared platforms keep that creativity from turning into chaos. The third principle is assign accountability. Nowhere is this clearer than healthcare. Robotic-assisted surgery sounds like a story about machines replacing surgeons, but that is not what the best-known systems do. The Da Vinci surgical system extends the surgeon's hands through a console and robotic instruments. The FDA describes these systems as computer-assisted surgical devices that require direct human control. They are not autonomous surgeons. Intuitive reported nearly 2.7 million Da Vinci procedures in 2024, with nearly 17 million cumulative procedures on the platform. The success story is human judgment amplified by precision, dexterity, visualization, and training. The surgeon chooses the plan, responds to anatomy, manages complications, communicates with the clinical team, and remains accountable to the patient. Even the famous Operation Lindbergh in 2001, where surgeons in New York operated on a patient in France through teleoperation, proved the same point. Remote control is possible, but it depends on latency, local clinical teams, backup procedures, consent, regulation, and a named human chain of responsibility. Accountability has to be designed before scale, not repaired after failure. That means deciding which decisions the system can recommend, which decisions require approval, who can override the machine, how audit logs are stored, when the system must stop, and how errors are investigated. It also means resisting the vague language companies sometimes use when nobody wants to own a hard decision. A workflow cannot be accountable. A dashboard cannot be accountable. A vendor contract cannot be accountable. People and institutions are accountable. The strongest human-machine teams do not hide the human. They make the human role more explicit. The operator becomes supervisor, reviewer, trainer, exception handler, and accountable decision-maker. That may sound less futuristic than full autonomy, but it is exactly why it works in regulated environments. Trust grows when people know where judgment lives. The fourth principle is learn through measured pilots. Pilot is not a press release. A serious pilot defines the task, the baseline, the users, the risk, the failure mode, and the metric that would make expansion worthwhile. GitHub Copilot is a useful example because the early evidence was measured at task level. In a controlled study, developers with access to Copilot completed a programming task about 56% faster than those without it. That does not mean every developer on every codebase in every situation becomes 56% more productive. It means the organization found a measurable improvement in a specific workflow, then had to learn where the tool helps, where it creates review burden, and where human expertise remains essential. The right question is not, did the AI look impressive? The right questions are, did cycle time fall? Did quality hold? Did review effort change? Did security risk rise? Did developers trust it? And did the team ship better software? Good pilots create knowledge, not slogans. The fifth principle is embed into operations. This is where AI stops being a project and becomes infrastructure. In logistics and fulfillment, the lesson is visible. Amazon describes large-scale robotics as supporting employees by moving inventory, simplifying repetitive tasks, and improving safety. Ocado uses robotic warehouses, simulations, and orchestration systems to coordinate physical movement at high speed. The pattern is not one robot replacing one worker in isolation. The pattern is a redesigned environment. Sensors, software, robots, human stations, exception handling, maintenance, digital twins, safety protocols, and continuous optimization. Once embedded, the technology has to be staffed, repaired, monitored, upgraded, audited, and taught. Someone has to understand why a robot stopped, why a model drifted, why a queue backed up, and why a customer promise was missed. The operation changes so the technology can actually perform. When you put the 5 principles together, successful AI starts to look less like magic and more like management discipline. The organization begins with a real workflow, connects the data and context. It names who is accountable. It runs pilots that teach the truth. Then it embeds the system into training, support, controls, maintenance, budgeting, and leadership routines. This is why durable AI requires more than data scientists. It needs frontline experts, process owners, lawyers, finance leaders, security teams, change managers, engineers, and operators. It also needs patience. Real transformation rarely arrives as one heroic launch. It arrives through thousands of small design choices. Better instructions, cleaner data, clearer escalation paths, tighter feedback loops, calmer interfaces, safer defaults, and leaders willing to change incentives. The winning companies are not the ones that worship the model. They are the ones that redesign the human system around the machine and the machine around the human system. This is the real difference between AI theater and AI value. Theater shows a model answering questions on a clean screen. Value shows a nurse with fewer avoidable clicks, a surgeon with steadier instruments, a farmer spraying less chemical, a driver wasting fewer miles, an advisor spending more time with clients, or an engineer finding defects before they reach production. Theater asks whether the machine can perform a task. Value asks whether the whole system becomes safer, faster, cheaper, fairer, more resilient, or more humane. It asks whether customers notice better service, whether employees feel more capable, whether risk is easier to trace, and whether the company can repeat the improvement without heroic effort. That is the standard executives should use before they scale anything. So the path forward is neither panic nor blind optimism. AI will keep getting more capable. Robots will become more precise. Software agents will handle more complex workflows. But the organizations that create lasting value will not be the ones that pretend humans are disposable. They will be the ones that understand which human roles become more important when machines become more capable. Judgment, context, empathy, responsibility, coordination, oversight, and trust. Scale is not a guarantee, but it is a practical way to ask better questions before the money, politics, and hype take over. It reminds leaders that successful AI is not just a technical architecture. It is a social contract about how work should improve. In the next episode, we will go one step deeper and explore the new human jobs AI creates, from AI supervisors and workflow designers to accountability owners and machine team managers.